technology.
Oh, there it is.
It looks, yeah.
Got it, friends. I think we're live here, at least on Monday morning, the 16th of May. Yeah. It is time once again, stargazers, to check out the cosmos, as well as planets and nebulas and black holes, supernovas, rocket launches, galaxies. We cover it all here on the weekly SBAU Astro Hour, done exclusively for the South Coast longtime Astrophysics and Telescope Club, the Santa Barbara Astronomical Unit. It's each and every Monday morning on Zoom, 11 to noon, and seen on YouTube. We're back on this week. Check us out, sbau.org. I'm your host, Vice President of the club. Proud to say Ron Heron is my name. And I'm going to introduce you to the crowd. A lot of people are missing today. Our outreach guy is doing outreach somewhere. And Tom Whittemore is on bread baking assignment. And Tom Totten is busy elsewhere. But we got Bruce back on the bottom of the screen, recovering from injuries. Bruce, you feeling okay? Bruce Murdoch?
It only hurts when I breathe.
All right, stop breathing. No. Don't need to breathe, for crying out loud.
No, this zero gravity chair, which is on loan from a neighbor, is wonderful. I have no pain when I'm in it, but when I get up, and I have a big bruise in my back, about a foot in diameter. So
you got a good sound out of that headset you're wearing this time. For some reason, cleared up.
Well, you know, I'm my modem, my Wi-Fi is one story above where I am, so there's some attenuation of this radio signal, and I think that helps.
Okay, well, thank you for joining us. President is running the show these days. President Jerry Wilson, 4 times at the helm. How are you, Jerry? And your little man cave, and Pat Forgy is your wife. Bruce's wife is named Bonnie.
Bonnie.
And on the screen are 2 other faces we have not seen before, but we've invited them on since we're a little shorthanded. More the merrier. There's Chrissy Cook, who is our astronomy programs coordinator for the Santa Barbara Museum of Natural History and a NASA Solar System ambassadress, or ambassador, I guess, these days. Along with longtime member, telescope expert Tim Crawford, Starhopper. Tim, you are married to Karen.
That's right.
All right. And if you have a partner, my dear Chrissy, you can name that person, but otherwise we'll just plunge ahead with the headlines. Good to have you.
I do. His name is Kevin, and he's great. Hi, honey.
All right, fantastic. I'll remember.
Let me also add that Chrissy is representing the Santa Barbara Museum of Natural History.
Yes, she is. I did say that, but we hope to get back in there by August. Can I announce that? I just did. We had a grand time Saturday afternoon at the meeting, the board meeting, 5:30. Kicked around a lot of stuff, and then we had another record-breaking Saturday night star party. Everybody was at except me.
How many people were there?
I don't know, Mr. President.
I think we had around 150 is the count that I got at the end of the night for Saturday night at the star party.
Wow.
So strong numbers.
So is this the second live one? We had 3.
This is the third, yeah.
Third, okay. Well, the opening 2 months ago was like 500 plus, I understand.
Yeah, last month was around that too. I think as much as, we were sad not as many people came, we were a little relieved not as many people came. It was a little bit of a zoo those first couple star parties, and it was a nice space this time around.
It was we were overrun that first one. Everybody thought because of COVID and because we'd been off for 2 years that nobody'd show, and it was just the opposite. Everybody came out of woodwork.
Well, then I have a good feeling about our first live meeting back in Farron Hall in a couple of months. I'm wondering if that'll be well attended, if everybody gets the word. Let's see. We also did a Sunday afternoon get together out at Camino Real Marketplace, and that was also well attended. Many of you went to that. Bruce didn't for obvious reasons, but Chrissy, how was that received by the public?
Again, our numbers were strong, over 300. I didn't get the final count yet, but fantastic. People of all ages and audiences. I heard a lot of people speaking a lot of different languages. A really good mix of all kinds of awesome people that were excited and engaged, and everyone was oohing and ahhing all night long. Of course, everyone in the SBAU was super engaging and helpful and interesting, and I got nothing but positive feedback from the public about everyone they interacted with.
Good.
We're looking
How
at
was the viewing of the lunar eclipse there?
We're looking at it. Oh, there we are. That's the back of Tim.
That's the back of
No.
Chuck, and you can see the moon right here.
Oh, yeah.
On that's the first rise. That's our eastern horizon. And it was darker than this. The camera, of course, adjusts for the light.
Okay, I don't see it, but I'll take your word for it.
Well, you can see a little white spot there, Ron, and that's before it got to totality, and the upper right portion of the moon was it was washed in white, so it was brighter at that point. But as it rose, it got darker.
Yeah, it looks like a fingernail clipping sticking up right there.
Right. It was it went into darkness pretty quick.
Yeah.
Would that have been an L0? We'll learn about L later. That's called.
Yeah, coming up next.
Yeah, we'll talk about that. Can I just read you something real quick? This is a Twitter feed from Neil deGrasse Tyson. He said, Wayward Planet. Oh, he's with Hayward Planetarium. Dear Earthlings, currently in darkness. Right about now, the full moon is passing into Earth's conical shadow in space. He said the event is long and boring, lasting 3.5 hours, but for the middle 84 minutes, though, the moon is all but fully darkened as it enters the deepest part of Earth's shadow. Shall we talk about that incredible limit scale that somebody named, Langeron?
Just one more picture of the eclipse last night. Unfortunately, everybody here is looking to the left, but the actual eclipse is to the right. I don't know what they're all looking at. I think Mercury was up there and someone pointed it out.
Oh,
that is weird.
You can see on the TV screen the progress of the eclipse. This is in the umbra. This is that sliver of light that hasn't gone into totality yet.
You're right. They're looking west. That's where the sun sets.
Yep.
I can tell. Does the market or whatever, the Camino Real, does it shut down at 9 or 10 and we go when they shut down, obviously? Do they ever leave us out there in the dark with everything turned off?
Oh no, the lights were on the whole time.
Yeah.
Okay,
Except for a few brief moments of hope.
And the businesses are still open till we're there, till it's over.
Most of the businesses were, everything was closed by the time we were leaving, except for maybe one late night movie. Yeah, all the restaurants were closed. Starbucks was closed.
Okay.
Oh, Starbucks was closed.
Very good. So we had a grand time there and well attended. Man, people want to get out. They think the pandemic is over. Keep those masks. Here we go. Mr. President, you want to explain this scale named for somebody named Langeron?
Yes. Heat back, I think it was in 19, it was what?
DA, I may have put an L on the beginning. It's a Langeron plan.
Oh, anyway, can you read? I don't have the talking points in front of me, but what day or what year did he invent this or come up with this scale?
I didn't get that far, but I got
1921.
Thank you.
Okay.
So 1921, came up with, it's a very subjective scale. It's not used much. I have seen it a couple times, but this is the scale. So I would say ours was definitely an L0.
I took a picture if you'd like to see.
Sure.
Oh boy.
Can you share your screen and do that?
Yeah, you probably need to unshare yours first.
Okay.
All right, let's see.
Amazing how this technology works. Ooh, blood moon.
Yeah, so that's a picture I took a little past maximum eclipse, just held up my cell phone to a camera or to a telescope eyepiece.
Looks like an L3 to me, brick red.
Oh, you can't judge it from a camera because the camera does its own light adjustment.
Right, exactly.
The scale this guy developed is a visual scale.
Yeah. I would say definitely objectively looking at that night, it was a lot darker than the photo indicates.
Yeah.
I had it at about a L1, L0 to L1.
Really?
Between those two.
Okay, so the moon was totally within the conical shape because it gets skinnier, doesn't it? The shadow of the Earth.
And the lights, it's really hard to judge it because the lights out there was so many sidewalk lamps, and then in the pit where we were at, there was all kinds of lights, and somebody had turned them off at one point. Then they turned, the crowd would cheer, and then they'd go back on and they'd boo, and then they'd go back off and they'd cheer. So we don't know what was going on with that, but it was really difficult to judge between L0 and L1.
So to my eyes, I could not see any C's on the moon when it was at totality.
Really?
Jerry, I just sent you my picture of the moon at totality taken with a 500mm lens on my camera.
Oh, cool.
Where did you send it to me? Can you, yeah.
We
Email?
Email.
Uh-huh.
Where did I send it? I sent it to
Well, that's the president here now doubling as webmaster.
Jerry A. Wilson, PhD at gmail.com.
That's me.
Where would you like it sent?
No, that's fine. I just got to find where it is where my email is on my machine. I stage everything in the order I'm going to show it. So.
Well, we still got the cartoons to do after this story, but I guess we're talking LO or L0, L1. Are the lighter ones like L3 and L4 because the moon isn't totally covered? It's only partially covered. Is that the reason, do you suppose, by the Earth's shadow?
Well, this one wasn't fully covered either.
Oh, it wasn't. Yet
I didn't. I saw my pictures don't show that. They show it lighter on one side than the other.
Well,
I can chip in on one thing here. Is that we had a lady come by I had some 10 by 50 binoculars, and she came by and she says, "Why is it red?" And I thought she was saying, "Well, why is the moon red tonight?" And I said, "Didn't you know there's a lunar eclipse?" And she said, "Yeah, I knew that, but why is it red?" And so it turns out that the light's refracted around the Earth, and it depends on the quality of the air, really, to what you get in those L1 to L4, or I mean L0 to L4. It really makes a difference what kind of air it goes through.
Yeah.
All right.
I tell them the moon is illuminated by everybody else's sunset.
Yeah, that's a good line that sticks with people.
Ladies and gentlemen, time for our levity. These are some of the forwarded silly science cartoons. Let's see how scientific this is. The man and woman talking in their living room. She says, "How else would I keep my solar panels in the sun all day and all over kitty cat?" Like you could probably connect those to a cat and it would keep it. Okay, that's good, Jared. Not one of the four I have listed here.
No, but it was one we
left
didn't
over
get to last week, and I said I'd find it again.
Well,
I love that one. I know where all the sunny spots are at the different times of the year in my house, and it's my favorite thing. I should get myself a solar panel, save on my electricity bill, because I just love to be there in that sunny spot.
Well, you sent 4, Jerry. Need a bigger boat? It's a Ziggy cartoon, or closer look, surprise, and getting up there. Do you have those 4 archived? Can you share them with you? Okay, can you enlarge that?
Oh, yeah.
All right. Scientist standing with a lady assistant in front of the big periodic table of elements mounted on the wall, points to one square, says, "Hey, right there, do you see it?" She exclaims, "Oh my God, I can't believe it." Sure enough, a wide-eyed, open-mouth emoji is pictured on the square, and it's labeled element of surprise. Ta-da. Thank you. Do you have any of the others? Or you want to save them for next week? Jerry, you're doing good. It's got to stop. Nothing? Because we try to get a little levity going here with science cartoons.
We've had a lot of it sent to us of late.
Here are the 2 Vikings, a couple of aging Norse pillagers seated at an ancient table looking over pill bottles and meds for some reason they've recently come into possession of. One of the bearded gents says to the other, "Face it, Sven, we're old. Pillage just doesn't mean what it used to." So pillage.
Oh, now I get it. I didn't get that the first time I saw it.
A little play on words, a little pun. Okay.
I just want to jump in quick to say that on the chat on YouTube, Jim Williams has chimed in to say that the eclipse in Lompoc was eclipsed by a giant nebula, aka cloud cover.
Oh.
Sorry, Jim. I heard that from a lot of friends around the country. There are places with tornado warnings and thunderstorms and all kinds of stuff, and they all missed the eclipse. So lucky us in Santa Barbara, I guess.
Yeah, we were the one clear spot. Yeah, that's a bummer, Jim.
Speaking of Lompoc, Elon Musk launched another, several dozen telescope or satellites on
Yeah,
satellite.
Starlinks. Yeah.
Right. Oh, here we go. Man and his dog are on.
Actually, yeah.
Say that again. What did you
No,
say?
go ahead.
Okay, they're lying on the roof. Man talking to, I guess, his dog. It looks
Yeah.
like talking dog says, "You know, the moon has a weird spot on it. I don't get this. You're going to have to explain it." Man says, "I don't see it." Dog continues, "Right there. Look closer." And the man responds, "Oh, there it is."
See, he stood up. That got him closer to the moon.
Oh, okay. All right. Silliness abounds. All right. You're doing good. Sooner or later, you'll have it just as fast down as Tom Totten used to bring things up.
Tom is the master.
Well, you're catching up. Do you ever need a bigger boat? The Ziggy cartoon? Man standing outside of the, yeah, there he is. Wishing on a star, twinkling star, though, answers him back. Wait a minute. What? You wish his world peace? Haven't you heard about Putin? Hey, I'm just a dwarf star. You're going to need to wish on a red supergiant like Betelgeuse or something that big. Dun, 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 dun.
Yeah, gets me in the feels a little bit.
That's a serious one.
Yeah.
Oh, Tim, see what you did there.
Well, if you're on the list, you'll get these forwarded silly science cartoons, everybody. Can we talk about the picture everybody's talking about in our universe, our little baby black hole? All 4 million worth of suns in the middle that they actually took a picture to, like they did, what was it, M87 weeks ago?
M82, I thought.
Maybe it was 82. I thought it was, I heard it was 87.
It was M87
Okay.
last year.
I think maybe 2019. Yeah, it's been a while.
Did you have that in the talking points? Can you call it up? Here it is. We're going to show you a picture.
There it is.
Okay, that's not exactly a picture of the black hole. It's what's around it, pretty much.
The black hole is in here. This is the accretion disk around it.
3 blobs.
What's that?
3 blobs.
Yeah. Now this was taken with radio telescopes. It's not a visible image. It's a radio image in the millimeter wavelength band. It was taken by radio telescopes coordinated over the entire Earth. And this is actually a sharper picture of our galaxy's black hole instead of M87's black hole.
Right.
Because we are closer to it. And we had the advantage this time of using a solar telescope array in Antarctica, which could not get to the other one. It was set all the time for the M87. So this was taken, I believe, in 2017, and the data was analyzed and put together into an image over the intervening 5 years.
How much data was like 3.5 petabytes of data, something insane like that?
Yeah.
That was like, because it was like 300 million gigabytes of data.
So
well, they used 7 telescopes. Yeah.
So
they used 7 telescopes around the world, each of which had an atomic clock that was accurate to a nanosecond. So they were able to record all their individual images with time, slot, whatever, time on it.
Timestamp.
And then they put those on hard drives and sent them to the one location where they were played back and reassembled as though they were in real time.
Yep.
I thought that was unique.
Amazingly enough, that's the way pictures of the Earth from weather satellites are taken.
Oh, really? Okay.
The computations on board the satellite is not done. An image is not generated on the satellite because that would put a computer up in space, which is a harsh environment, and you'd get a lot of bit errors from radiation and stuff. So what they do is they just record the output from each detector and they put a timestamp on it. And then they send it to Earth. And then that timestamp is used to do all of the processing to generate the image in real time, or not in real time, but close to it. So you get it for the next day's weather.
So,
Barry,
yeah.
I saw a program on TV after this image was up, and one of the scientists was saying that what's so astounding about it is it verifies exactly what Einstein predicted in relativity.
Yes,
and
it's
that
the model. The model of what it should look like is exactly this. So it's taken as a significant verification of general relativity again.
That's amazing.
Yeah.
Well, this accretion disk we're looking at mostly is stuff, it's either the full stars going in or stuff off the stars. I assume it's going in, not being pushed out.
A lot of it, most of it, I think, goes out. It collides with itself. It's a crowded situation. You know, everybody's heading for the exit all at once, and the exit is into the black hole, and they can't make it. They bounce off. So a lot of the crap comes out as two beams along the poles of the black hole, and a small portion of it gets bounced to the black hole.
Wow.
Why are there 3 big lumps?
I can't answer that.
You're supposed to know everything.
I can speak to that a little bit. As they were collecting the data, what's tricky is that everything is actually moving really, really, really quickly. So even as they were taking the data was constantly shifting. So this is actually a stacked image of hundreds and hundreds of images, and they kind of lumped them into 4 different groups based on the spatial patterns that they saw to kind of come up with an average picture. This wasn't like it looks like this instant. It was like, you know, over a few instances, it looked this way. So in the composite of all that data, it came out looking sort of like this. But there are plenty of images where there's a different, there's one that you can't even see the event horizon as clearly, like a data set of many images where they all came out like that. A different data set where there's 3 sort of bulges, but they're in different places. A totally different data set that has more like 2 bulges. So this had by far the most number of images matched this model, and they composited those together with the others. Why there are 3 in this, then more than 2 or 4, that I don't know about. I don't think we're still trying to suss all of that out. But that's why this particular image has those 3 bulges compared to other images that they selected or didn't select for the composite image.
Do any of you know what we call our Milky Way's super black hole? The name of it? It's named after a constellation.
Probably Sagittarius something or other.
I mean, it's this.
Star.
Right, exactly. Sagittarius A star, not like typed out star, but like asterisk. It looks like asterisk when you see it in print, but we say star.
I think there is another star just called Sagittarius A, isn't there? I saw it.
This is inside of that. Sagittarius A is a nebula.
Okay. Well, it's hard to understand why anything would be leaving a black hole, but if you say so, I guess it's being expelled.
No,
Things are very energetic there. It's a real fist fight.
So chances are, since this looks like M87's black hole, they probably all look like this in most of the galaxies.
Very similar.
And Chrissy, what did you call it? A million gigabytes? What's it called?
A petabyte is a million gigas.
PETA or
PETA.
Yeah.
Wow.
Yeah.
That's 10 to the 15th.
Whoa.
Yeah, it's a lot. A petabyte of anything is a lot.
Yeah.
Yeah.
Yeah, if you're not familiar with the term, you might not get the enormity.
I've never
Now
heard
that we
of
all know,
that.
it's a big number. It means really big.
right?
It's bigger than a
Yeah.
terabyte. It's bigger than a lot of stuff. Yeah.
I remember when we went into that room out at LCO-GT, Los Cumbres Observatory, and that room that he had was just filled with all the servers and stuff. They were just, and every one of those was just gigabytes. It was just gigantic room. So I don't know what his capacity is there, but it's huge.
Yeah, we're right now in the planetarium where you have a presentation that is talking about a bunch of different observatories in Chile, and they're talking about how one of the observatories they're building that's part of the ALMA network in one night gets more data than the Hubble Space Telescope takes in a year because the resolution of the cameras is higher and they're getting more data. So, I mean, the amount of data that we're getting with the technology that we have, we're going to have to start thinking about things in bigger terms than we used to, for sure.
It's a good thing we came up with nanotechnology. Can you imagine putting one of those on those old reels? The old computers that had like.
Oh, that would be hopeless.
Before we leave black hole, 2 questions. We're just a little quiz here for you guys. How far away and how many suns is it worth? How far
Well, it's
away?
about 26,000 light years away. That's how
Wow.
far our sun is from the center of the galaxy, 26 or 7,000 light years away, give or take, depending on our position.
Okay, and how big is it? How thick? How heavy? How many solar masses? How many million?
Well, big and massive are two different questions.
Yeah.
Oh, they are?
Yeah, it's about the size of a city inside,
Oh, that kind of massive.
and but it's very massive. It's in the talking points, I
I
think.
think it's around, was it like 4 million maybe solar
Something
masses?
like that, yeah.
You
That
got it.
was in the millions. Yeah.
Yeah.
And they have made the Milky Way bigger than 100,000 light years across. It's bigger now,
It's
right?
now 200,000.
Oh my God. It'll be as big as Andromeda before long. What are we looking at now, Jerry? What story shall we do? Got a lot to cover.
This is Tim's, one of Tim's star hopping charts.
Oh,
Yeah, exactly. Whenever we have the NGC 457 or the owl cluster, this is a really neat one for the kids, because you can, around Halloween, you can tell them, do you want to see a flying owl up in the sky? And it's kind of in the right, it's kind of right in the middle of the Cassiopeia constellation. But the way I find it with a star hop is really easy. You take this Kappa Cassiopeia, I don't know how to say that, Cassiopeia, and then you draw a line right through the center of the big W, which is that star called Navi there. And then you make a right angle approximately with Rukba. And right at the right angle, that's where the owl cluster is. I was looking at this last night and I was thinking, good grief, I could just draw a straight line from Kappa Cassiopeia and through Navi and go equidistance, and you'd just be right on top of it as well. But when I show the public, I just take the little green laser and I show them that star hop by drawing a line from Kappa Cassiopeia through Navi and then making a right angle.
I'm glad Tim sent this stuff in, because this is absolutely the best way to learn the sky, because here's the constellation of Cassiopeia, which is easy to spot. It's the W or M, depending on the time of year. And if you want to find something through your finder scope, you won't be able to see this cluster in general. So you do on a star chart beforehand, and you figure out this simple pattern of lines to follow, to point at where it is. And then you set your finder scope on that, and then it'll be in the main scope. Now, the star cluster, I think you probably could see this in a finder scope, but a lot of nebulas and galaxies you don't, like especially planetaries, because you can't tell them apart, and you certainly can't see them for size in your finder because they're very small. But it's an excellent way to learn the sky. And
it's exactly right, Jerry.
We skip by this when we have go-to systems now on our computer.
The only trouble with star hopping is there comes a time when you're going to be in the middle of just a dark spot, like Cancer, which you've got coming up. And star hopping there, it's tough. If I wanted to go and find Iota Cancri, it would be really tough star hopping. But, the best thing you can say is, well, it's between Gemini and what's on the other side there.
Well, gentlemen, this sucker has a lot of names. NGC 457, Owl Cluster. It's Caldwell 13. It's called the Skiing Cluster, the ET Cluster, the Kachina Doll Cluster, and Dragonfly Cluster. How do you get an owl out of it?
Very easy.
I don't see it myself, but
well, it's when usually at the scope, I tell people, especially down here in the city, completely different in the mountains, but down here in the city, you just tell them, look for the two brighter stars. And the two brighter stars, the whole cluster itself is about 8,000 light years away, but the two brighter stars are the eyes of the owl. And then you can look for the wings outspread and tail feathers behind it, and it's flying through the sky in whatever direction it's going. But the two brighter stars in general, those are the eyes of the owl. And also, why they call it the ET cluster is from the movie, when you see that guy going phone home, his arms are all spread out, and you see his eyes pretty widespread. And when you look at it through the telescope, it kind of looks that way.
You're talking ET? Is that what you're saying?
Yeah, exactly.
Yeah. There you go. That's a good picture.
In here, you see the two brighter stars. This is the eyes of the owl. And to the right and left at about a 45-degree angle, that's the wings of the owl. And then the tail feathers go down towards that yellow star at the tail. And that's what you see through the telescope. But if you're up in the mountains, you kind of see this. You see all there's just I don't know how many, 50 stars or 55 stars in the cluster. When you get up 2,000 feet in the air and you take a look at this, it's hard to spot because there's just a lot more stars.
Well, William Herschel discovered it 1787. Is he the guy that got us Uranus or Neptune, one of those two planets? Herschel?
Yeah, Uranus.
Uranus.
And I think that's William Herschel, isn't it?
Yeah, that's what I said. 1787. It's
Chrissy, do you recall who did Uranus?
Yeah, that was Herschel.
Yeah, good.
All right. 7,900 light years away. 21.
Probably Caroline.
Say again? Oh.
Yeah.
And it's 21 million years old. All the stars together, or the whole star cluster is 21 million, or just one of the stars?
No, well, it's a cluster. So if you have a distance for one, you pretty much have it for the whole congregation there.
Really? Okay. Fascinating stuff. Cassiopeia. Well, let's keep it alive with clusters. You want to go to the Beehive? That's M44 in Cancer, like Tim was telling us a moment ago. Now high in the western sky at sunset, a couple hours after dark, still 30 degrees above the horizon. Bright cluster of stars visible by your totally nude, undressed naked eye at magnitude 3.7. It spans nearly 100 arc minutes, and it's right there in the center of Cancer, the Crab.
So this is the western sky at 11 o'clock at night on May 17th. That'd be Tuesday, but it's not going to change much at that time. It is setting, so if you wait much later in the evening, it gets too far down and behind the hills for my place. But the red bullseye is on M44,
which is a whole cluster, huh?
And I'm going to tell you a little trick I like to use to find Cancer in the first place, because it's not very bright, like Tim was saying. You just want to look in between Gemini and Cancer, and you want to look for the flux capacitor from Back to the Future. Remember that thing that powers the car, and they go back in time and forward in time? It looks like this shape, these three spokes coming off the middle. That's Cancer the Crab. And the Beehive cluster is right in the center. And that's how I just look for the flux capacitor.
Yeah.
We see a cluster of stars, like one star, like it's one pinpoint of light.
Oh, that'd be a globular cluster. This is an open cluster, and it's a very big one. You can actually see it with your naked eye under dark skies.
But it would be a fuzzy.
Yeah, we saw it once from the gun club. It was to the west, I guess, and it was amazing. It was big. You could see it.
Yeah.
Well, just like there were 55 in the other one that we just talked about, how many do they have them counted? Is this the number of stars, what we're looking at?
This is the Beehive cluster.
It's not much of a beehive.
But yes.
Interesting.
Whatever you say goes out on the air here.
Do you suppose any two of those stars are under a light year apart?
I have a microphone right here.
Gary, are they really close? Are they light months apart?
That's a question I don't know, but I would guess that they're closer than, as a congregation, if we were in that, we'd see a lot more bright stars, and they're probably on the order of 1 to 5 light years apart.
I wonder if science knows. I wonder if science knows how close big things like stars can get before they start orbiting.
Oh, in the congregation, you can just watch them and plot their orbits around the common center. But these kind of clusters don't hold themselves together that strongly by gravity like a globular cluster would. What happened was there was a nebula like the Orion Nebula, and parts of the nebula coalesced under local gravitational attraction to produce. And as the stars turned on, they blew the remaining dust away. So this is a nebula that has produced stars and then the nebula is blown away, so you get the star cluster. This is how our star, our sun, was born in a similar situation. And there is a program ongoing to try and find the sister stars of ours from that nebula, from that first cluster, a loose cluster like this. We've been around the galaxies, I think 17 times or something, or can't be that many, but a large number of times. And our cluster has, because everything's in a slightly different orbit, they all spread out and go their separate ways eventually. So this will not hold itself together by its gravitational attraction.
Just this one, or most clusters you're talking about?
No, this particular cluster too, and in principle, all open clusters, and including the open cluster our sun came from.
They don't ever coalesce into a black hole or anything?
Individually, a star might do that, but as a group, no. And globular clusters don't coalesce into a black hole as a group either.
And there's a lot of clusters.
Oh, that's it. Leo's on the other side. You go, Cancer's kind of between Gemini and Leo. So that's kind of, if you can see those really easily in the sky, then Cancer's, it's just an empty spot when you're looking at it, unless you have binoculars. Then it gets really pretty easy to see.
Now, this picture did capture a galaxy in the far distance beyond the stars. All these stars you see in our galaxy horse.
Oh yeah, did.
There's an interesting little set of 3 stars in a line down here. And I'm sure it's just a chance arrangement of the galaxy, of the line of sight.
I'm sorry, you're saying those are galaxies instead of stars?
Oh, no, this is a galaxy.
Wow.
I don't see any other galaxies, that there might be other ones in there. But every one of the stars you see is a star in our galaxy.
Oh, wow.
Can every Messier object be seen by the naked eye?
No.
No? Okay.
In a dark sky you can, but not here.
Well, some of them are too small, like M57. I don't ever hope to see that by naked eye.
Okay, so.
Or M51.
Just.
Yeah, M51. I don't know, but you see, there's two dominant colors of stars here. There's blue, white, and yellow. So, Baron, which one is hotter?
Blue, white.
Yeah.
But now, this is the beehive we're looking at right now, Jerry?
Yes.
Because it says that it contains 350 stars. That seems like not quite 350.
Well, the real dynamic ones with the diffraction bars on them do not total 350, but there's other stars that are less bright. Here, they have faint things. Here, and those things, it can easily total 350. What you need to do is measure the distance to each of these stars, and then you can tell what's in the cluster or not.
Okay, 600.
You might mention that in this cluster, there's and like Chrissy was saying, it's kind of a 3-legged spoke object.
Oh, that's the constellation, yeah.
Yeah, and you can look at it as a Y as well. And at the bottom of the Y leg, there's Iota Cancri, a really beautiful double. But Chuck had to find that using all the digital, the Altaz. I couldn't just go up there and find that.
I found it by accident, just trying to find the beehive cluster. It's the only way I've ever found it, is when I can't find the beehive cluster.
Yeah, and it's a really beautiful double. When we were out at a star party here, that had some pretty strong ambient light coming in, and Chuck was able to pull that in because he knew where it was. But Iota Cancri would be up to the right of this 3-legged spoke. I think that it'd be up above that, Jerry, straight on that leg. Yeah, up in.
But these stars, to me,
there.
Remember, this is a planetarium software, the Sky 6, and then that represents bright stars as bigger stars. These are not terribly bright. So to find Cancer, I'd have to study the sky to find the 3-spoked.
Oh,
arranged
yeah.
in here.
I see
like
it
I
as
said,
an upside down
it's an empty
V.
spot.
Yeah,
Well, you can always stop by the planetarium, anyone who's watching or listening, and we'll be happy to give you another tutorial on how to find it.
bingo.
Yeah, exactly.
You know, an interesting thought about clusters is that science fiction writers probably have a grand time making them maybe neighborhoods of intelligent life that can communicate and go back and forth between the stars. Unlike traveling here, it would take probably too long, but maybe within a cluster, that could be Star Wars, you know?
Well, we could get to Alpha Centauri the same as people travel among clusters. We have yet to cross that bridge, though.
Okay. But just one last thing that you put in your notes, I thought I'd share with everybody here. An odd thing to remember, along with Orion Nebula, M42, and the Pleiades, which is M45, the Beehive is not usually mistaken for comets. Nevertheless, old Messier cataloged them as fuzzy objects.
Yeah.
As long as we're up there, you want to talk about Corvus the
He
Crow?
was trying to pad his list because other people were getting awards for having these catalogs, and so all of a sudden he put them together and published them.
Well, is it a fuzzy object in a telescope or just from the naked eye point of view?
Naked eye.
Oh, okay. So he got his he did have a telescope, I assume.
Yes, he did.
And the original list was about 45 objects, because I think M46 was the next one that he had to catalog. And now it's 110 objects, but his original list was 45.
Then there's the Caldwell list, and then there's the MGC.
There's all kinds of stuff.
Smithsonian, they got their list too.
Patrick Moore, the famous English amateur and astronomy spokesperson, the Neil deGrasse Tyson of Britain, he had started his own catalog, but because his last name was Moore, his catalog would have been M again, so that would compete with Messier. So he used his middle name, Caldwell.
Caldwell.
Oh, I didn't know that.
Okay.
Nice.
Yeah, are there as many? 110 Caldwells out there?
No, there's 110 Messier objects. I don't know how big the Caldwell catalog is. There's probably a catalog of catalogs.
So it's a little like Fahrenheit versus it's a little like Fahrenheit versus Celsius versus Kelvin, whichever country you drive on the left side of the road.
No, those things each have their own specific application, the reason they were invented. Fahrenheit was invented so America could stay off the metric system. That was a joke. So and the Kelvin is more scientifically useful.
Is it? It's not the same as Celsius, is it? It's totally
different. Is. I mean, the degrees are the same, but there's a 273.15 degree difference.
There's an additive difference to go between the two.
Right.
It's not 9/5 or 5/9 like the difference between Fahrenheit and Celsius.
Well, President Jerry, if you want to save Corvus the Crow and the Great Square of Pegasus, we got some interesting little things that you didn't have a lot about. Hubble saw a smiling face, which we all know what that is about, and Bard's spiral showed a box-shaped bulge. That I didn't get. And Mars is being circled by an orbiter from China that's going to land. You want to go to?
Well, that's at least a year old thing. I put it up there because it had a crescent, Mars as a crescent. That was an interesting photo. But the lander that's talked about in the talking points has already landed about a year ago, and it's chugging around on Mars.
Oh, I thought it had a Utopia Planitia. Okay, so how about the smiling face? You got that great picture.
Okay.
Smiley face in space, if you can find it. Hubble, which I didn't realize was partly ESA. It's NASA and European Space Agencies behind the Hubble. Galaxy Cluster 50, 55, 32, 381. My God. Gray lensing. Is that what it's called? Gravitational lensing. I put down GRAV and made the V look like a Y. Ha! Hi, boys and girls. Okay. I don't know.
There is a galaxy cluster in here. And galaxy clusters have a tremendous mass. And the mass of this one is so great that it bends the light of galaxies farther away around itself and acts as a lens. So these things here, how do I get the other cursor? I guess I don't. Okay. Anyway, these lumps around here are other galaxies far, far away that are sort of lensed around here. It's not a highly corrected lens, but it is very useful. You can capture the light, look at its spectra. And this one has two galaxies appropriately or conveniently placed in front of that, as part of that lens or in front of the lens to give it this shape of two eyes and nose. Einstein's happy face.
That is great.
Usually you just see a ring like this or a ring like that. There was one I was going to show last week, but I didn't get to it, that has a perfect ring and then 4 spots around it. So it has the lensed ring and the Einstein cross. This I call the Einstein happy face.
So Jerry, those the ones that create the smile and those are galaxies way further away.
Yeah, those are the galaxies that are being imaged by the gravity of this cluster that's located in here.
In front of it.
In front of, well, in front of the galaxies that are distorted around the ring.
And it magnifies them?
It
Bends them.
Yeah, it bends them around. It does magnify them, but it mostly distorts them.
Like a funhouse mirror if it were a sphere. Imagine like a weird rounded funhouse mirror that just bends the light all kinds of weird ways.
Right. But it does brighten them a bit, and that's how we're able to see them. These things are very useful. There's not a lot of them, and you can see a lot of galaxies back here.
God, yeah.
Well, matter of fact, most of these things are galaxies. I think that's a star.
And the nose is a galaxy as well?
That one, most likely, yes. These are definitely galaxies.
That is really something.
Well, why is there a Einstein cross? The 4 blobs, left, right, top, and bottom. Why does that happen?
It happens because of the symmetry of the gravity that's bending the light. One part of the cluster that's in front bends the light and produces a star image, and another one produces another star image off to the slightly beside it. So like they're not real well focused and they're not real well corrected. It produces it like if the James Webb Space Telescope, if it had not worked, it did work, but if it hadn't worked, each mirror would be producing its own image. So each part of the galaxy cluster is producing its own image, and that's why you get the cross, for example.
Can you point to Einstein cross for me?
I'm sorry, Bruce, your voice broke up.
Can you out Einstein cross for me, please?
You're breaking up, Bruce. Sorry.
Well, I'll move on now. How about hear me?
Some of it we can
Back to
understand.
the same problem, aren't we?
Yes.
A little.
Can you? The problem is standing waves. I was asking, can you hear me now?
Yeah.
Point out the Einstein cross to me, please.
Oh, this is not a picture of the Einstein cross.
Oh, okay.
That was one last week. If you want to bear with me for a moment, I can try to find it.
Well, I had a question I wanted to ask all you astronomer telescope experts, and it might be the same phenomenon. Every time I see a star pictured that has been taken a shot of, it's got 4 points sticking out, left, right, up, and down, or sometimes 8.
Yeah, that's the spikes.
Why does that happen?
A lot of times those are created by the arms of the diagonal holder.
Yeah.
So a lot of times they're created by, what do we call it, the spider? So those are the cross members that go through a telescope tube that are holding the diagonal mirror. And it's also the reason why some of the telescope builders now, they make a hoop that holds the diagonal in the center of the scope, and that hoop gets rid of the spikes. But then
spreads them out.
and then people backed out of that and they said, well, I kind of like the spikes. And so they went back to the old style of spiders, and they get the spikes and the stars with the spikes in it, and it is pretty. You know?
That's certainly the way they're portrayed in paintings and Disney animation. Pinocchio wished on a spike star.
When I built my 10-inch Dob, and I was building one alongside a guy that was doing his doctorate in physics at UCSB. Very poor, and he was a dumpster diver. So while I was getting all these really cool little store-bought spiders, he was going into dumpsters and finding big hoops of metal, and he put his diagonal on that. And Jeremy Schmidt was his name. Really fantastic guy, professor in Kansas now at university. But Jeremy built the scope using just those magnificent brains of his, and it was quite a scope. So I was showing the spikes, he wasn't. It's really neat.
The Schmidt-Cassegrain scopes don't show the spikes.
They don't.
No, because they don't have the secondary mirrors in the middle of the glass in the front.
So they're just large white dots against a black sky.
Or it's a correction plate or a correction mirror.
Well, you get a different thing. If you defocus the scope, you'll find that the star image is a circle with a black dot in the middle.
Black dot in the middle?
Well, I guess that's the same in a Dobsonian. Yeah, it's a shadow of the secondary.
Yeah.
Tim, the structure inside the telescope itself, there's some sort of a bracing that puts those 4 spikes on.
Yeah, that bracing holds in a reflector type mirror. The bracing is called the spider. And that in the center of that spider, there's something that holds a diagonal mirror, and that whole mechanism there, it creates a shadow, which is what Bruce is referring to. If you get an image when you're out doing a star test, and the star test is it's taking a bright star in the sky.
I can't find that image. I'll have it up next week.
Oh, that'd be cool.
Very nice.
I like to see it myself.
Yeah.
And so you're defocusing a bright star. Some people say you can take Polaris so it doesn't move, and you focus inside focus and then outside focus, and there's diffraction rings that are formed. But with a reflector type telescope in that ring pattern, you're going to see a little shadow in the center, and that's your diagonal. It won't let the light through there. With a refractor telescope, you're not going to have that. It's just going to be clean. All the star rings all the diffraction rings, they go cleanly from the center all the way out.
Is this Andromeda we're looking at, Mr. President?
No, this is not Andromeda. This is another galaxy. This is for the square core. So galaxies have the disk, and then they have a core that's usually a central bulge. If you're looking end on, and the central bulge is a bar, like a barred spiral, then you're supposed to see a square, like here and there and there. So for me, it takes a little bit of imagination to see that. But because of that, this galaxy, even though we look at it edge on, is considered to be a barred spiral.
Which we are too, right?
We are also, but this is us.
Okay, so it's a long bar when you see it face on, but when you see it edge on, it's a box.
Yeah. Well, no, it's a bar. Yeah.
Bar with a lump in the middle. Looks like a flying saucer.
Yeah.
Is that a companion galaxy above, Jerry?
Say that again.
Is that a companion galaxy?
Yeah, these two galaxies are interacting. Here's one of the spiral arms of this galaxy that's been torn off by that one, or distorted off by that one.
Huh.
And here's one that's shooting way off into space.
Wow.
And we're looking at a box in the middle?
Well, there's kind of you have to be quantitative here, not qualitative, but there's a sort of a border here, and then there's a straight line across there, and then sort of a border there. And so that gives you what some people see as a box shape or a square shape in the middle. So there.
Oh, okay.
So, and that's how barred spirals apparently look, according to one article in the some physics letters journal.
Well, unless they have it nailed down, Jerry, that sounds like another mystery that has to be solved. How come some?
Boy, the universe is full of those.
Well, why do some spirals get a bar and others don't?
That's another one, yeah.
Yeah, interesting.
So what was the other thing you asked about? Mars. Oh, Mars.
Oh, Mars. Perseverance is sending out its little Ingenuity helicopter drone.
No, this one is just cool. I thought it's a cool picture because it shows Mars as a crescent. And this is from the Chinese orbiter.
Yeah.
For Mars. I'm not going to try and pronounce it. Chuck, I always rely on Chuck to pronounce the Chinese stuff.
It's the Tianwen-1.
Yeah, that's it.
Amazing. That's like 6,000 miles away or something.
Yeah, this is it's reminiscent of the time that Voyager went by Uranus, I believe, and took a dramatic crescent image of Uranus as a crescent. And that was in 1979, I think, when I was just getting out of grad school. It was very impressive.
Too bad we can't see little Phobos and Deimos. It's dinky little moons.
Yeah, we showed an eclipse by one of them within the last month. Very dramatic.
That eclipse was pretty spectacular.
Yeah.
In a potato, those small, they're that dinky? Are you kidding me? Was it a solar or lunar eclipse?
It was a solar eclipse, and it was nowhere near a total, what we call a total. Let me show you another thing real quick that is pretty cool.
Okay. Look at the moon behind Tim.
That's Tim's moon.
Good picture.
Yeah. Here we go.
This is Andromeda.
Oh my God. How possibly could we get a picture like that?
Yeah, that was.
Yeah, well, what you see is we're used to seeing it as a
edge on
part of a quarter foreshortened image, but you can project that image onto a plane that's tilted at the same angle that the galaxy is, and then you can photograph that face on. Now, of course, it makes all the stars look elliptical or long, and it makes it look like Andromeda has a bar in the middle, which it doesn't. That's just an effect of this technique. But it does straighten out all the arms of the galaxy, so you can see the actual structure of it as if you were looking face on for the galaxy.
Looks like a barred as well.
It does look like it's barred, but it has, I noticed, it has this major arm that goes all the way around and then out to here. And it has an interior arm, another second major arm, and then it has little connectors between the two. And this one even has a spur that goes out here, but then it kind of peters out. So very interesting structure.
Well,
what an interesting
they don't
technique.
actually project it and then take a picture. It's all done on the computer.
Yeah, it's all done on the computer from another.
Right.
I've seen pictures of the moon also back in the 50s and 60s at Griffith Observatory, where they made a Astro Paris model of the moon at a certain shape, and they projected photos from the Earth onto the moon, and then they photographed straight on, normal to the surface of the plaster model. And so it took the foreshortening out of the picture. So you could see craters that as if they looked straight on, and it changed their appearance quite a bit.
Well, from past YouTubes, when you guys talk about it, to me, it looks like this is spinning counterclockwise, but you've said, no, it's probably clockwise.
They go either way.
Okay. In this one, we wouldn't know which way it's going, or?
I can't tell, but it's easy to find out. You just put a spectroscope on one end and then the other, and you see what the Doppler shift is. And
okay.
It tells you which way it's going, whether the top edge is coming towards you or moving away.
Yeah, yeah.
That's easy peasy.
So
you answered the question. I don't know how. I was really blown away that they got this. I was thinking, like, how did they get this picture?
Well, it's laid out pretty much like the Milky Way, only bigger, isn't it?
I think it's slightly smaller than us, if I recall correctly. But the way our size is dependent on how you define the actual edge of it. And I used to think that believe that our galaxy was about 100,000 light years across, but I've seen numbers now up to 1,000,000 light years across. But of course, that's very faint trailing nebulosity and stars going way out. But the structure you easily see and identify as the galaxy is about 100 or 120,000 light years. And I think we're about two-thirds of the way out. So 2/3 of 50 is about, what, 30? So,
Yeah.
so about 29 or
It's
30,000 light years from, okay.
40 or 40.
Okay, so we're somewhere in there. I think Chrissy quoted 29,000 or 26,000. So
Yeah, 26,000.
Yeah, that's what I remember. So
What they say is it's coming toward us. Are we also going toward it?
yes,
Relative.
we're going to meet them halfway. It's a friendly get together.
Coming at
It all
7.
depends what your point of reference is.
Yes, exactly.
We still and they're coming to us, or they can be still and we're going to them.
Yeah,
You know,
it's relative.
Uh-oh. That's a signal that we're over?
I don't
I have
know. We have a long time, but we are a minute over. So
All right. Well, look, everybody, thank you very much for joining us, and maybe we'll get some of the regulars back. And there's no reason, Jerry, to not have Tim or Chrissy back with us again sometime.
Hey, thanks for the invite. It was fun.
yeah,
Great to be here.
You're invited to any future meeting you want to make. If you want to come
Right.
to us, just sign in.
We'll
You have
work it
to
out.
go.
Bruce, you get better. You hear? Get
Yeah.
those-
Please, yes.
Yeah,
Yeah,
Jim
me
Williams
too.
also sends his best to you, Bruce, in the Google chat or the YouTube
Oh,
chat.
by the way, I got a very nice card signed by a lot of the people in the AU, including Jerry and Tim.
Yeah.
And I thank you very much. When I get better, I'm going to respond to them.
Okay. Well, I hope you get better.
First, get better.
Yeah.
At the board meeting last Saturday, we all voted in money for a first alert button around your neck. Next time you fall apart.
No, I don't need that.
I can't get up.
Jim wants to nominate you for an AU Purple Heart.
All right.
I have a purple back.
Yeah.
Great big bruise.
It will go away.
Man, man. All right, everybody. Thank you.
Bye. Bye.